Okay, hello student, welcome back, and today we are going to continue our revision for SPM. As usual, I would like to repeat this, which is no need to read your science book already. Now is the time to just do exercise. Still got. Okay, so plan your time properly. So there's 10 days. So make sure you many things you can do. Just make sure you plan your time properly. Okay, let's read the question number 1. Yeah. First thing you do is always understand the question. If we cannot understand the question, then then please read again the question. No point to not understand the question and try to answer. Then your answer is going to be everywhere. So make sure not only this question, when people talking with us or when the teacher explaining something, I always check whether the question got mistake or not. Sometimes that is the question got mistake. When people talk to me or business proposal or exam question, make sure that the question you understand the question. Study the following information. Okay, so there's a fridge, store the fish, and there's a fish at the room temperature. Okay, so obviously I think this fish will be smelly, and this one at the fridge, the fish will last longer, maybe for another 1-2 months before it rot. Fish in the refrigerator can last longer than the room temperature. State one problem statement of the health. So what is the problem statement for this one?
How does temperature affect food preservation?
How does, sorry?
How does temperature
Uh-huh.
affect food preservation?
Okay. Wait, where is my textbook? How does temperature affect
Food preservation.
food preservation? Well, let me think for a while. How does temperature affect food preservation?
Actually, this one is about food preservation or growth of bacteria of growth of microorganisms.
Mm, Wait, let me read the following question. Yeah, actually,
Microorganism. I can't see the question below, so yeah.
yeah. No. So this one student need to be smarter a bit. Actually, both is correct.
Yeah.
So how does temperature
Affect
affect
growth of microorganism.
growth of microorganism? Actually, both is correct. That is why things get makes student confused, because problem statement, hypothesis. Hypothesis is like the title for the experiment, and sometimes the question asks you what is the problem statement or what is the hypothesis, and when we look at the question, we really don't know, because both is correct. If you say the first one is correct, how the temperature affect food preservation is correct, how does the temperature affect the growth of microorganism is correct, but Malaysia education, we need to follow marking scheme. So you pandai-pandai a bit. So that's why when I read the following question, because the first question it didn't mention anything. So but as you read in the C question, it state that given experiment, they say experiment investigate the growth of bacteria. So now that we know that the question is talking something about growth of bacteria. So either you want to use the word microorganism or bacteria will be the most suitable, and this one is not suitable, though I think it's correct. Actually, I think it's correct, but we teacher, we need to follow the marking scheme, and well, I would say maybe the question is not designed properly, or maybe the question is designed properly, the question is designed for student to read the C in order to get the A. I don't know, maybe they want to design like this. Anyway, you guys pandai-pandai lah. When you exam, you pandai-pandai study lah. Suggest one okay, so now we have the problem statement, so we can do the hypothesis already.
Yeah.
So what is the hypothesis?
The higher the temperature,
The higher the temperature,
the lower the growth of microorganisms.
No. Wait, I write down first. The higher the temperature, the what?
The lower the growth of bacteria.
The lower the growth. The lower, whatever lah, the higher or lower, whatever lah, higher or lower bacteria growth.
Lower should be because temperature is high right?
Okay, I put lower. Lower. But this one is wrong, or why is it wrong?
Wrong
Yeah.
Wrong.
Yeah lah.
Sorry. The lower the temperature, the lower the temperature.
Lower then I put lower already
Lower the temperature,
The lower
bacteria growth.
The lower the temperature. Also wrong
Wrong
Yeah. Why?
It's about temperature and bacteria growth not it?
Yep, correct. But the student will get this wrong. This one not only, I think, yeah, this is the common mistake lah, that student will get this wrong. The thing is, when we put the hypothesis is something that you want to test. So when you say the higher the temperature, the lower the it is saying very ambiguous, because of ambiguous means unclear. High temperature means what? High temperature. Some people 10 Celsius is high, 1 Celsius also is high. And some people will say low is what? Low could be 0, negative 273 Celsius. 10 Celsius for me is very low. So it is ambiguous, so the student didn't get any point. So how can we improve the hypothesis?
Bacteria growth is optimum at room temperature.
Yes. Bacteria growth is optimum at room temperature. Very good. Or there's bacteria grow faster at room temperature, or optimal growth. So now we solve the problem of ambiguous, because the first one is we don't know which one is more clear. Because the word of high and low, I don't know. Now we say room temperature, we can give it a correct, because room temperature means how much room temperature?
23?
Yeah, around
26.
I don't know lah, around your room temperature lah, 20 to 30 lah, roughly around 20 to 26. But it's roughly we know that is the room temperature. Or if you don't want to use the room temperature, if you want, you can use either freezing point. Bacteria will not grow at freezing point or boiling point, so it will be more specific. Actually, this one you can do like this, maybe in university lah. After you do this, you need to give definition of low temperature or definition of high temperature below your hypothesis, and this will be better, because it is easier for the reader to understand. Okay, next question. So now we can test, because hypothesis is something that we want to test. So you say that bacteria optimal growth. So now we can test the experiment. So you can imagine, one I put in the fridge, maybe one I go and put in the oven very hot, I don't know if you like, or make it dry at 50 Celsius, 60 Celsius on the hot sun. And another one I put at room temperature. So we can study the thing, the thing that we want to study. But here don't have the sun up to you lah. But if you are designing the experiment, I will not say it's not wrong. Not only it's not wrong, it is it's even better, because you are showing more data to your result, that you are telling me that after the conclusion, the growth of bacteria will be optimal at room temperature, not too high, not too low. But the question only use freezing point optimal, so never mind, just okay. Yeah, but you understand lah. Okay, let's read the question. Where the given information PMP design elaborate experiment to investigate the growth of bacteria after different temperature by using two sterilized label in A and B, bacterial culture solution, sterilized nitrate agar, cellophane tape. Cellophane tape. I thought cellophane is a brand name. It's yeah, cellophane. Cellophane is not a brand name. I thought it's the brand name. That's called the tape only. Wire loop, refrigerator, and thermometer. Describe the experiment to test the hypothesis in 11b. Okay, aim of the experiment. What's the aim of the experiment?
Aim of to study the effect of temperature on bacterial growth.
To study
Effect
the
of temperature on bacterial growth.
on bacteria growth. Very good. Okay, identification of variable. So how to do this question?
Okay, manipulated variable, constant variable, and responding variable.
Okay, so what is the manipulated variable?
Manipulated is temperature.
Okay, temperature.
Then responding is
Responding is
area of clear region.
area of
Clear region.
clear region. Okay,
Then constant is type of bacteria.
type of bacteria. Some more? Any more constant variable? Amount of what?
Amount of bacterial culture.
Bacteria culture. Okay, very good. Of course, there's a few. Usually, constant variable there is a few. In order to make sure that we are able to test the variable, so we want to test the temperature effect on the bacteria growth. So there's a area of clear region, or if you want to say number of colonies, up to you. Okay, both is correct. If you understand, then you will get this correct. But wait, I don't know where to put this. Just put it here lah. No place to put. Okay, procedure. Can you tell me the procedure?
Procedure. Okay. For this question, right, my teacher asked me to draw out the diagram, then label, then write procedure.
Very good.
So
Okay, let me draw. You let me know if I draw correct or wrong. So probably I will draw why I always got no place but let me create some empty space. Where to draw leh? I just here lah. Where's my eraser? Wait, I'm looking for my eraser. Okay, let's assume I draw the diagram at here. Probably I draw 2 petri dish, but correct. 2 petri dish, and then I put here A, put here B, and the dot is it? I think that should be enough. Any more things I need to add?
I don't think so.
Yeah, okay, so can you tell me the procedure? Now I know I already draw. So basically we understand that A, maybe we want to put as either way lah, room temperature or what. B, maybe I want to put it as cold, up to you lah. So can you tell me the procedure? 4 marks, so maybe we want to write at least 4 points.
Okay. Prepare the apparatus.
Prepare the apparatus, okay.
Okay, then number 2. Pour the bacterial culture solution.
Pour the bacterial culture solution, okay.
On top of the nutrient agar.
Pour bacteria solution on. Okay, next.
nutrient agar. Then cover the petri dish
Cover the petri dish. Okay.
and seal it with tape, with cellophane tape.
With cellophane tape. Okay.
Then keep the petri dish in a dark cupboard at room temperature.
At room temperature. Okay.
Then repeat the step
Repeat the step.
and keep the second petri dish in refrigerator.
Separate the dish in refrigerator. That's it.
Then observe for 3 days.
Observe for 3 days.
Then record your experiment. Okay.
Record the experiment. Okay, very good. I think the student will roughly get full mark for this one, but let's adjust this answer
Okay.
just to make it better. Okay. Okay. Let's see how can we. This is correct lah. I will probably give the student full mark. The reason is the student show that he is able to understand the answers, show that the student able to understand and trying to explain the answer as clear as possible, because for this one impossible to get the student answer exactly the same as the marking scheme, but the most important thing is the student able to answer, showing that he understand the concept. Okay, prepare the apparatus. Maybe we can prepare the cameras as in figure A. So maybe you want to label that as a figure A. Label it figure A at here. Pour the bacteria. Why they spill my bacteria like that? Pour the bacteria solution into the nutrient agar. Wait, let me read the question for a while. They have a wire loop, refrigerator, thermometer. Okay, sterilized culture solution. Okay.
Wire loop. What's the wire loop for?
What's the wire loop for? Okay, so prepare apparatus figure A, pour the bacteria on solution agar. This one you need to, maybe you want to say this, pour bacteria solution on nutrient agar petri dish A, for example.
Okay.
So that it is clear that you want to pour the nutrient on petri A. Cover the petri dish and seal it with a cellophane tape. Okay. Repeat the step. So repeat steps. Maybe you can say here, repeat step 2 and keep with repeat step 2 by putting the second petri dish. Okay, repeat steps 2 by putting second petri dish in the reference. So it must be at least clear lah. Repeat step means what step? Step 1, step 2, step 3. So repeat step 2 by putting the second petri dish in the refrigerator. Observation, observe it for maybe 3 days. Record the experiment. Maybe I like to write record. Observe the record your observation. Okay, can record the observation. Record the observation. Okay, can. Or collect the data. Okay, I put here. Collect the data and record the observation. Okay, very good. You can add more lah, like see the numbers of colonies, see the clear region, stating the temperature if you want to any like when we say something like keep the battery in the dark cupboard, okay lah, can lah, because here also get dark cupboard. Okay, anyway, it's very good. Tabulate the data. So what should I do to tabulate the data? So this one, should I use pie chart, table, or histogram, or graph, or line chart, or what should I do?
Just the normal chart.
Normal chart means
Rows and column.
row and column. Table.
Yes, table.
Table, okay. Then
Yeah, then
put here A and B lah.
3 times 2. 3 times 2.
3 times 2, okay. Then here I put the manipulated variable. Here I
Yes.
put the responding variable. Okay?
But then wait. Oh yes.
Yeah, okay. So
Yeah, correct.
because I lazy to write, I put here Petri dish, Petri
Yeah.
A and B, and you
Temperature then.
yeah, MV is the temperature, and the responding variable will be maybe you put numbers of colonies or what. I forget to bring my pen, so that's why I just use my mouse to draw something like this. So I think for SPM, usually tabulation is only for table and a line chart. A line chart, or it could be histogram.
Where my mom is calling me. Where?
Okay, so for SPM, I think it will be either table and a line chart. How can I know it's a table or line chart?
Line chart.
I mean, like it's a
Usually also table lah.
usually it's table. So
It's all table.
yeah, if a line chart, here will be the MV, here manipulated variable, which is the temperature, and here will be the responding variable. These are very normal that you should understand in terms of mathematics, science, physics, chemistry, whatever. Usually it's always the MV is on the x-axis and y. And for the table chart, usually you start with manipulated variable first, then only the responding variable. It will be a table form if the data, it depends on the data that you are going to collect. Because this is called a categorical data, means it is category of A and B with bacteria and no bacteria. So it's 2 category or 3 category, maybe boiling or not boiling or what temperature is a category. So we in a category data collection, we always use a table. If the data is maybe ratio or interval, means in terms of number that is possibility go to 0. For example, maybe it's a temperature. You want to do in fact of a temperature to the bacteria growth. Then maybe you might want to do histogram. So it's also possible. But since you say it is only category like room temperature and what, this one, is there any example? Maybe rate of reaction, or speed, where the data that you collect can be 0 or the scale shows something, or age. It shows that there is a proper numbering system and it is scale. So we use the line chart and for this one there. Of course, there is also pie chart. There is also histogram, but I don't think SPM will be coming out. These are 2 types of variation: continuous variation and discontinuous variation. So what is continuous variation and discontinuous variation?
Is show significant differences.
Yes, okay. So diagram 10 show a various character of human being. Discontinuous birth group, presence of dimple, ability to roll tongue, and type of earlobe. What is the question?
Wait, A haven't do it.
A haven't do that. Give 4 differences. So what is the 4 differences between continuous variation and discontinuous variation?
First one, continuous does not show significant differences. Then discontinuous shows significant differences.
Okay.
Then continuous variation can be measured.
Okay.
Then discontinuous cannot be measured.
Okay.
Enough ah? Can ah? 4 already. Can ah?
No lah, need another
Two
2
only
more.
ah?
Yeah lah.
Aiyo. Then what ah? Oh yeah. Continuous variation. The graph is a histogram.
Graph is continuation graph is normal,
Histogram.
and discontinuous variation
It's a bar chart.
graph is graph is not a normal distribution.
Oh, normal distribution.
Okay, this one is it. Okay, I put continuous variation do not show obvious characteristic. Some more, last one.
Still got one.
Maybe we can say that continuous variation is not inherited.
Oh, inherited. Okay.
Yeah, let's correct all this grammar. I like this software. Okay, so of course I write in the short form lah. Continuous variation do not show obvious characteristic. However, this continuous variation show obvious characteristic. Continuous variation can be measured. Discontinuous variation cannot be measured. That's why continuous variation we want to use a graph. It makes sense.
Yes.
Because it can be measured, so it makes sense when you want to draw a line graph. But for discontinuous variation, you cannot measure, so you want to use a table form like blood group or maybe whatever lah, because it's category. So there's no point doing graph already. Continuous variation graph is normal. If you got study maths, you know that a normal means it is like sometimes it like a bell. That is a normal. It's a bell that you can see, and if not normal means it go up and down like a stock market. So it's not a bell curve. Continuous variation is not inherited. For example, like what?
Weight.
Weight. Or height. Yeah, very good. So it is not inherited. Usually all people grow will become tall, and usually all people grow will become heavier. So it is a bell curve that we can see that how the distribution is, and for the blood group and what it is totally we cannot see the bell or the thing that we want to see. Okay, diagram 10 show a various characteristic of human being. So this is a discontinuous. Rotang, blah 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 blah. Study the first that oh my goodness, construct the concept of discontinuous variation. So how to
construct the concept means explain or how?
Okay, so what it means by actually this question is a I feel it's a difficult question lah. So you can choose 13, is it? So usually most students will choose.
Can choose the
because in a research paper you must able to write out the. Actually, it's just to explain the concept.
Yeah.
When you do a research, there is a certain concept that you want to. I mean, when you're doing an experiment, that it must be backed by a certain literature review and concept. You cannot say I want to do a research and it is zero concept. Means is when you say I want to do something with zero concept means you are doing a paper without other people never do before, other people never understand before, other people don't know anything. It's really totally something new. So it is impossible impossible to do. So there must be a certain concept that we already know, that we already understand, that we want to derive from also the knowledge information that we know. So maybe we can say that the first concept that we can say that this one and this one and this one and this one is a discontinuous variation. Okay, this is the concept I want to say. And then we can say that another example is like fingerprint or type of hair. Another example that we want to show. Non-example, for example, non-example like height and weight. Common characteristic, maybe we can say it is inherited and it is influenced by genetic factor. You get what I mean or not? Yeah, so it means that when you do this question, actually it is to able to conceptualize the hypothesis that you are going to do. The hypothesis you are going to do is, where's the hypothesis? Where's the hypothesis? We didn't do the hypothesis. We don't, but roughly don't have the hypothesis. We don't have the hypothesis. Okay, so we roughly we know lah, the topic that they are wanting to share is the discontinuous variation, and we want to expand the concept. So we want to say I just write out the keyword, the concept keyword. Where's my text box? The first concept. Okay, why don't you tell me what are the few concepts that you want to talk about this? I think since we don't have hypothesis, we take the topic. The topic is discontinuous variation. So what are the concepts in discontinuous variation?
It's inherited.
Yeah, okay, wait, just let me put my text box. Oh my goodness, I just want to put, what is this? Where's my text box? Text box is this, but why my text box become blue color? What is happening? Yeah, you're saying the concept. So we know the topic. So it is the concept of discontinuous variation. So what are the concepts that you want to say?
So I just explain.
Yeah, explain the concept.
So discontinuous variation are variations that show significant differences.
Okay, variation that shows significant differences. Okay, any more concept?
Characteristics of discontinuous variations are permanent.
Discontinuous are permanent. Very good. Some more?
And can give an example.
Can.
So for example, blood group, fingerprint,
okay,
or the ability to roll tongue.
Print or ability to roll down. Okay, last one.
Discontinuous variations are normally presented using bar chart.
Okay, bar chart. Maybe we can say that it being influenced by genetic. Okay, because I didn't say the bar chart because that is the data collection part. So if the question asks, but I don't think they will ask why you want to use that, then only you explain, because the data is a categorical data. Okay, so these are the concept. Okay, there's the difference between concept and definition. Definition means when we ask something, the people explain the something. That is called definition. What is when you're talking about room temperature, can you give an operation definition of room temperature in this segment? Can you give the operational definition of discontinuous variation, or can you give the operational definition of ability to roll tongue, for example? That is the definition. But concept means something that is more. You want to explain more. So concept is more than definition. It explain more. So of course I just type shortcut lah. I don't want to type lah because it's 6 mark ma. So of course 6 mark you don't type like that. Okay, you need to explain more. So maybe we can say the concept of continuous variation. I just say lah. I don't want to type lah. Later it will take 1 hour. Continuous variation show a significant differences. Okay, another concept you can write either number 2. The concept of the characteristic of discontinuous variation are permanent. It cannot be changed. And then maybe you can write the following one. Okay, this characteristic can be changed, or the another concept is it cannot be changed due to genetic. But the next concept will be genetic, where discontinuous variation is formed from genetic factor that is affected by the parent cell, for example. So that is the fourth figure. And then we can say a very good example for genetic factor and inheritance factor will be the blood group, fingerprint, ability to roll tongue. So that will be the thing. So basically it's more like explanation of the concept that we already know. So we don't start the experiment from zero. Then people will ask you what are you trying to do now? Then we say we are trying to do is, but I cannot say what we are trying to do because I cannot get the hypothesis. I don't know what is the hypothesis, so I don't. So usually we have a hypothesis, then we have the concept, then only we start with the, then we have the hypothesis, we have the variable, then sometimes we have the concept, then only we start with the procedure, then the discussion, then the discussion also we can put in concept, then we have the conclusion. So your experiment will be more comprehensive. When people read, wow, it is something else. It's very good experiment paper that we want to do. And regardless, it is not too easy, not too difficult. You might want to go for this one because for this question, I don't think, because it is just this thing that you already know, so it might be not that difficult. In your opinion, the variation is important. So do you think it's important, yes or no?
Yes.
Yes. So I also think it's important. Why? Justify.
Variation produces new species.
Variation what?
Produces new species.
What piece?
New species.
New species. Okay, very good. And
for the sustainability of all species on Earth.
Sustainability of species. Maybe I say it will distinguish characteristic, or maybe produce new characteristic or variation, or maybe resistance to disease, because you have variation, so you are more prone to more better to resist disease in terms of animals and also plant, correct?
Okay.
Yeah. So of course, like for example, you want to create variation. That's why we have for example, like meiosis. So because of meiosis, we have different blood group. Your daddy is A, your mommy is B. So you could be AB, you could be A, you could be B, you could be O. Due to the variation, your mother is blue eye, your daddy is brown eye. So maybe you got white eye, I don't know. So that will be the variation, and it is better to have a variation. Why is it better? For example, you can produce new species, very debatable, because they will ask what do you define by species, but we are SPM only, so we are not going to that. Okay, distinguish the characteristic, yes. Create a new variation and more resistant to disease. Of course, if you have a better variation, then it's better. For example, like we can see, let's say, Western people married to Eastern people usually has a breeding of a stronger and more better offspring. So we can see the son is more handsome because it's a mixed plant, also the same, animals also same. You want to crossbreed it so that you get a better characteristic of the next species. So you want to learn this. So then now you know science, you can do business. So you can crossbreed and you can sell your better cow, or you can crossbreed and sell a better meat or milk or plant and so on. So yep, there's a 2 mark. Okay. So we take a short break and I see you back at 12:40.
Okay.
Okay, see you. Bye.